This is Veeranjaniya Murali. Today my topic is common base configuration. Before going to the today's topic, let me tell something about a transistor. Transistor, a device which can control the electrical current by acting like a amplifier or a switch. Transistors are of two types, PNP transistor and NPN transistor. Each transistor has three terminals. In that, one is emitter, another one is collector, and third one is the base. In PNP transistor, the emitter and collectors are positive and the base is the negative. In NPN transistor, emitter and collectors are negative and base is the positive.
Transistor, a device which controls the electrical flow by acting like an amplifier or like a switch. This is base, this is collector, and this is emitter. This is the transistor and it is represented as like this one. It has three terminals. One is base, one is collector, another one is the emitter. One is emitter, second one is base, third one is collector. Transistors are of two types. One is PNP transistor, another one is NPN transistor. PNP transistor, this is collector, this is emitter, this is collector, and this is base. The circuit representation of the NPN transition is collector, base, and emitter. Another one is NPN transistor. In this, emitter, collector, and this is one is base, NPN. Symbolic representation of NPN transistor is collector, base, emitter.
Let's coming to the today's topic, common base configuration. It is a transistor circuit arrangement where the base of the transistor is connected to the both input and output of the transistor. When a common base configuration is forward bias, it is said when the emitter base junction is forward and the collector base junction is
common base configuration. Let us consider a PNP transistor. Emitter, base, collector. Common base configuration forward when the emitter base junction is forward. That means VBC positive terminal is connected to emitter and the negative terminal is connected to base. And collector and base junction is reverse bias. That means base is connected to positive terminal and negative is connected to the collector. The VCB is the voltage. Here input current is IE and output current is the IC, where IP is current due to majority electrons. Electrons కాదు, holes. INE current due to majority electrons, and IR is the recombination current. IPC is the current due to minority holes. IPC naught is the current due to less amount of holes, and IC naught is the current due to minority electrons. Here input quantity is IE into VEB and output quantity is IC into VCB. Input current and voltage around the emitter and base junction VEB are independent, and IE and VCB are independent on the input current. Input characteristic. We are draw the input characteristic in between the input quantities by keeping the output quantities are constant. In x-axis we consider VEB, on y-axis we consider IE in milliamperes. In forward bias, the current is increases less up to the breaking voltage V gamma. After the cutting voltage, it increases exponentially. VCB is equal 0 volts. V gamma is for silicon. V gamma is 0.7 volts. For germanium, V gamma is 0.3 volts. VCB equal to 1 volt. VCB equal to 2 volts. Output characteristic. Here we draw characteristic. We draw the current in output characteristic in between the output quantities VCB and IC. We take IC as y-axis and VCB as the y-axis. Here IE equal to is 0 milliamperes and IE is 1 milliamperes. IE is 3 milliamperes. This is the cutoff region. This is common base config in forward bias, and this is saturation region, and this is active region.
Thank you guys for giving this wonderful opportunity. Thank you.